Hello from once. Welcome for our biology class. We are still on cell physiology. We just started it last week. And this is our 5th lesson. We started by looking at the properties of a cell membrane. And we say that a cell membrane is selectively permeable. Can allow very tiny particles to pass across, or we say it is semi-permeable. Cell membrane is also called plasma membrane, and it allows the movement of substances into and out of the cell. That is what we concluded. Now, based on the properties of cell membrane and its functions, we are talking of a case where substances are moving in and out. So today we want to look at those processes that aid in the movement of substances into and out of the cell. Those processes are what we have listed there as our subtopic, which we call physiological processes. So our subtopic today is physiological processes. The objective of our session is to state and describe the physiological processes. To state and describe the physiological processes. Now, we said that the cell membrane has the ability to control the movement of substances into and out of the cell. And that the movement of substances into and out of the cell is achieved by 3 processes that are called physiological processes. So one is diffusion, another one is osmosis, and the third one is active transport. So the 3 physiological processes that will take 90% of our discussion on this topic are diffusion, osmosis, and active transport. Now, let us look at what we call diffusion. And for us to understand this term, we are going to do a small demonstration here. And so in our practical activity today, we have to demonstrate diffusion using potassium manganate 7. So I want us to understand what is happening during diffusion, and then from there we will come up with the definition for the term. So the requirements: we require potassium manganate 7. Potassium manganate 7 is normally purple in color, dark, shiny purple crystals. Then we have water. We need a glass tubing. In my case, I will be using a straw. Then, now we are set to go. I also have my spatula here, which I will be using. So the first procedure is to hold a glass tubing vertically in a beaker, so that one end of the tubing rests flat on the bottom of the beaker. So this is my tubing. I will place it vertically that way, so that it rests inside. Then number 2, carefully drop a crystal of potassium manganate through the upper opening of the glass tubing. A crystal. So they are telling us to take only a crystal. I will select one crystal. So I'm going to use my paper. Yes. Then I'm going to drop. Yes. Then the next one, close the upper end of the glass tubing with the thumb. Half fill with water. Already there is water inside, and then carefully withdraw the vertical tubing. So we are going to withdraw it. So let us study what is going after 15 minutes, observe and record. So that is what we are required to do. Let us see what will happen in our setup. Let us see what will happen in our setup. We have to leave it for some time. We have to leave it for some time. So meanwhile, as we are waiting, we have dropped a crystal inside that water. And we are supposed to observe what is happening. You can see that the purple color of potassium manganate 7, the purple color of potassium manganate 7 is spreading slowly. You can see that the purple color is spreading slowly. So just leave it there as it spreads and observe it carefully. And observe it carefully. So our discussion, as I have said, as we wait for the changes to take place, our discussion will concentrate on these three processes. One is diffusion. Two will be osmosis. And three will be active transport. So today we are looking at the first one. And now, so as time, this thing needs 15 minutes, but we can discuss, then we will observe at the end of our session. Now, from this diagram here, you can see the piece of potassium manganate 7. You can see the piece of potassium manganate 7. Then you can see the particles are spreading out until the water becomes uniformly purple. So the particles are spreading out. But why do you find that the particles will spread out slowly? Now, the reason why the particles are spreading out, remember matter is made up of tiny particles which are in continuous random motion. These particles are normally moving. They possess kinetic energy. But now it is upon us to analyze how they move. How do they move? Now, for us to understand how they move, I want us to look at one video here. And in that video, we will see what is actually happening. So in this video illustrates the process of diffusion. This is water. This is water. And it is a clean water. that is a clean Lua water. So if a drop of ink is placed in water, it dissolves and its particles move so that they are evenly distributed throughout the water. So you can see the drop of water, the drop of ink, sorry. You can see the drop of ink spreading. That one tells us that the particles are normally moving randomly. They possess kinetic energy. And how do they move? If you look at what is happening here, look at what is happening in our beaker here. The particles were concentrated, these are ink particles, they were concentrated in one point. Then, because of the movement of water molecules, because water molecules are moving and hitting these particles, so they spread out uniformly from where their number is high to where their number is low. So that movement will take place until the particles are uniformly distributed. Like this one, the particles are moving outwards. They will move like that until they are evenly distributed. Until they are evenly distributed. Now, let us just have a pause and then connect in the second segment.